This video is about being able to use the recurrence relation notation and to be able to write out sequences defined by a recurrence relation. Let's go through a lot of examples on how to answer questions to do with recurrence relations. Okay, let's start with A. So that means un, we've got un minus 1. So this is the next term, and this one is the previous term. So to get the next term, we do 3 times the previous term plus 1, where u1 is equal to 2. It means u2 will be 3 times the previous term, which is 2, plus 1, which is 7. To get u3, you're doing 3 times the previous term, which is 7, plus 1, which is 21 plus 1, which is 22. And u4 will be equal to 3 times the previous term, which is 22, plus 1, which is 67. Which means the sequence is 2, 7, 22, 67. Okay, B. So we got un and you got un minus 1. So this is the next term, and n minus 1 is the previous term. In this case, you have u1 is equal to 5. So to get the next term, you do 7, take away the previous term. So u2 will be 7, take away the previous term, which is 5, which gives you 2. To get u3, you do 7, take away the previous term, which is 2, which gives you 5. And u4 will be 7, take away the previous term, which is 5, which gives you 2. Which means you end up with the sequence 5, 2, 5, 2. Remember, we're only looking for the first 4 terms. So this B looks like it's a periodic sequence of order 2 because 5 and 2 are repeating themselves. Okay, now C. To get the next term, you're doing the previous term, add 20, divide by 10, where u1 is equal to 10. So u2 will be equal to 1 over 10 times the previous term, which is 10, plus 20, which is 30 divided by 10, which is 3. u3 will be 1 over 10 times the previous term, which is 3, plus 20, which is 23 divided by 10, which is 2.3. u4 will be equal to 1 over 10 times the previous term, which is 2.3, plus 20, which is 22.3 divided by 10, which is 2.23. Which means the sequence is 10, 3, 2.3, 2.23. Okay, for D, again, to get the next term, you're doing 1 over 2 plus the previous term. So D, u1 is equal to 0, u2 will be equal to 1 over 2 plus 0, which is equal to a half. u3 will be equal to 1 over 2 plus a half, which is equal to 1 over 5 over 2, which is equal to 2 over 5. u4 will be equal to 1 over 2 plus the previous term, which is 2 over 5, which is equal to 1 over 12 over 5, which is equal to 5 over 12. Which implies the sequence is 0, half, 2/5, and 5 over 12. So this is how you use the recurrence relation notation in order to form sequences. Next question. A sequence is defined by the recurrence relation ur plus 1 is equal to a times ur plus b. So this is the r plus 1 is the next term. To get the next term, you're doing a times the previous term plus b. So we've got u1 is equal to 10, we've got u2 is equal to 20, and you've got u3 is equal to 24. Okay, u1 is equal to 10. We can't do anything with that because that's the initial term. Now u2, using the recurrence relation, is equal to a times u1, which is a times 10, plus b. Maybe I should write that down. u2 will be a times u1 plus b, which implies u2 will be equal to a times 10 from what we've been given plus b, which is equal to 10a plus b, which means 10a plus b must be equal to the value we've been given for u2, which is 20. u3 is equal to a times u2 plus b. Now u2 is 20 from what we've been given, so u3 will be equal to a times 20 plus b, which is equal to 20a plus d. Itu 20a plus d multiplied by u3 but equation 1 and equation 2, what we realize is we've got b in both, so we can eliminate b. So if we do 2 take away 1, we get 10a is equal to 24 take away 20, which is 4. So a must be equal to 4 over 10, which means a is equal to 0.4. So we're trying to find first the value of a, then b, then u4. Okay, so that's a. To find b, we can use 10a. So using 10a plus b is equal to 20. We have 10 times 0.4 plus b is equal to 20, which implies 4 plus b is equal to 20, which implies b is equal to 16. So a is equal to 0.4, b is equal to 16. So ur plus 1 is equal to 0.4 times ur plus 16. So now if I find u4, u4 will be equal to 0.4 times u3 plus b, which is 16, which is equal to 0.4 times u3 we were given was 24 plus 16, and the value we get is 25.6. Okay, next question. A sequence is defined by un plus 1, which is the next term, is equal to the previous term plus c, where u1 is equal to 2, where c is a constant. Given that u5 is equal to 30, find a, the value of c. So u1 is equal to 2, u2 will be the previous term, u1 plus c, which means it's 2 plus c. To get u3 is u2 plus c, the previous term plus c, which is equal to 2 plus c plus c, which is equal to 2 plus 2c. To get u4, you're doing u3 plus c, which is equal to 2 plus 2c plus c, which is equal to 2 plus 3c. And u5 is equal to u4 plus c, which is equal to 2 plus 3c plus c, which is equal to 2 plus 4c. So what we do know is u5, we're given that u5 is equal to 30, which implies 2 plus 4c is equal to 30, which means 4c is equal to 28, which implies c is equal to 7. So that means we can rewrite un plus 1 is equal to un plus 7. Okay, an expression for un in terms of n. So that means if you got the first term is 2, 2 plus 7 is 9, 9 plus 7 is 16, 16 plus 7 is 23. We can see this is a linear sequence. So un will be equal to, because it's increasing by 7 each time, it means there's 7n. But the first term is 2, not 7, so we have to take away 5. So 7n take away 5 would be the answer for that part. Next question. A sequence is given by the recurrence relation un, which is the next term, is equal to half times k plus 3 times the previous term. Where n is greater than 1, u1 is equal to 2. So u1 is equal to 2. Find an expression for u3 in terms of the constant n. So if I want to find u2, it's half times k plus 3 times u1, which is equal to half times k plus 3 times 2, which is equal to half times k plus 6, which is equal to half k plus 3. u3 will be equal to half times k plus 3 times the previous term, which is u2, which is equal to half times k plus 3 times half k plus 3, which is equal to half times k plus 3 over 2k plus 9, which is equal to half times k plus 3 over 2k is 5 over 2k plus 9. If I times everything by half, I get 5 over 4k plus 9 over 2. B, given that u3 is equal to 7, so u3 is equal to 7 implies, find the value of k and the value of u4, implies, because we already worked out what u3 is, it's 5 over k plus 9 over 2 must be equal to 7, which implies 5 over 4k must be equal to 7, take away 9 over 2, 7 take away 9 over 2 is just 5 over 2, which means k must be equal to 5 over 2 divided by 5 over 4, which means k is equal to 2. So find the value of k and the value of, which means un can be written as half times 2 plus 3 times the previous term. Okay, so u4, which means if we want to find u4, we need to first find u3. u3 will be equal to 5 over 4 times 2 plus 9 over 2. If you put that into your calculator, you end up getting 7. So u3 is 7. To find u4, I have to do half times 2 plus 3 times the previous term, which is 7. So that will be 21 plus 23. 23 divided by 2 is 23 over 2. So u4 will be equal to 23 over 2. Next question. The terms of a sequence u1, u2, u3 are given by this recurrence relation, where un is the next term, 3 times un minus 1 is the previous term, where n is greater than 1, where k is a constant. Given that u1 is equal to minus 4, so u1 is equal to negative 4, find an expression for u2 and u3 in terms of k. So u2 will be 3 times u1 take away k, which is equal to 3 times negative 4 take away k, which is equal to negative 12 take away 3k. u3, so that's one answer, which is u2. u3 will be 3 times u2 take away k, which is equal to 3 times minus 12 minus 3k take away k, which is equal to 3 times minus 12 minus 4k, which is equal to minus 36 minus 36 minus 12k. So that would be u3. Given that also that u3, so for B, given also that u3 is equal to 7 times u2 plus 3, find the value of k. So that means u3, which is equal to minus 36 minus 12k, must be 7 lots of u2, which is minus 12 minus 3k plus 3, which means I get minus 36 minus 12k is equal to minus 84 plus 3, which is minus 81, take away 21k. If I move all the k's to the left-hand side, I get negative 12k plus 21k, which is equal to 9k. If I take the number constants all to the right-hand side, I get negative 81 plus 36, which is equal to negative 45, which means k must be equal to negative 45 divided by 9, which is equal to negative 5. So k must be equal to negative 5. So if I want to rewrite this, un is equal to 3 times un minus 1 plus 5. Because minus 5 becomes plus 5. C. find the value of u4. In order to find u4, I need to find u3. u3 is negative 36 minus 12 times k, which is minus 5, which is minus 36 plus 60, which is 24. So if u3 is 24, then u4 will be equal to 3 times the previous term, which is 24, plus 5, which is just the same thing as 29 times 3, which is equal to 87. A sequence of terms Tn is defined for n greater than 1 by the recurrence relation T sub n, which is the next term, is equal to k times T sub n minus 1, which is the previous term, plus 2, where k is a constant. Given that T1 is equal to 1.5, so T1 is equal to 1.5, find an expression for T2 and T3 in terms of k. So T2 will be equal to k times T1 plus 2, which is equal to k times 1.5 plus 2, which is equal to 1.5k plus 2. For T3, it will be k times the previous term, which is T2, plus 2, which is equal to k times 1.5 times k plus 2, which is equal to 1.5k squared plus 2k plus 2. So that is T3. B, given that T3 is equal to 12, so T3 is equal to 12, find the possible values of k. So we already worked out T3 is 1.5k squared plus 2k plus 2, and that is equal to 12. Which means if I take everything to the left-hand side, I get 1.5 squared plus 2k. 2 take away 12 is minus 10. If I double everything because I don't like the decimal, I get 3k squared plus 4k minus 20 equals 0. If I factorize it now, I've got 3k and k. I've got minus 2 here and plus 10 here. Then you get 10k minus 6k, which is positive 4k, which means k is equal to negative 10 over 3, or k is equal to 2. Okay, a sequence of terms is defined for n greater than or equal to 1 by the recurrence relation un plus 1, which is the next term, is k times un, which is previous term, plus 2, where k is a constant. Given that u1 is equal to 3, find an expression for u2. u2 will be equal to k times u1 plus 2, which is k times 3 plus 2, which is equal to 3k plus 2. B, hence find an expression for u3. u3 will be equal to k times u2 plus 2, which is k times 3k plus 2, which is equal to 3k squared plus 2k plus 2. C, given that u3 is equal to 42, so u3 is equal to 42 implies we already found the expression for u3, which is 3k squared plus 2k plus 2 must be equal to 42. If we take everything to the left-hand side, I get 3k squared plus 2k. Positive 2 take away 42 gives me minus 40 equals 0. I need to factorize this, which factorizes quite nicely to minus 10 here and positive 4. So the middle term gives me 12k minus 10k, which is 2k, which means k is equal to 10 over 3, or k is equal to negative 4. Next question, a sequence is defined for n greater than or equal to 1 by the recurrence relation un plus 1, which is equal to the next term is p lots of the previous term plus q, where u1 is equal to 2. Given that u2 is equal to minus 1, so u2 is equal to minus 1 and u3 is equal to 11, find the values of p and q. Because the first thing we know is u1 is an initial term, so we can't form an equation for that one. So u2 is also equal to P times U1 plus Q, which is equal to P times 2 plus Q, which is 2P plus Q. So if you put the two things together, we get 2P plus Q must be equal to -1. So this is equation 1. U3 is equal to P times U2 plus Q, because it's P times the previous term plus Q, which is P times U2 is -1 plus Q, which is equal to -P plus Q, which implies -P plus Q must be equal to U3, which is 11. So this is equation 2. Okay, I know we've got Q in both, so I can eliminate Q. So if I do 1 take away 2, equation 1 take away equation 2 means I get 2P minus P, which is equal to 3P, minus 1 take away 11 is -12, which implies P is equal to -12 divided by 3, which is equal to -4. Now using either one, so -P plus Q is equal to 11, implies I've got -4 plus Q is equal to 11, which implies 4 plus Q is equal to 11, which means Q is equal to 11 take away 4, Q is equal to 7. A sequence is given by x1 is equal to 2, xn plus 1, which is the next term, is equal to previous term times p minus 3 lots of the previous term. Okay, that looks a bit complicated. Where p is an integer, okay, integer. So remember, it's a whole number. Okay, show that x3 is equal to minus 10p squared plus 132p minus 432. So x1 is equal to 2. To find x2, we're doing x1, previous term, times p minus 3 lots of the previous term, which is equal to 2 times p minus 3 times 2, which is equal to 2 times p minus 6, which is equal to 2p minus 12. So that's x2. To find x3, we're doing the previous term, which is x2, times p minus 3 lots of the previous term, which is x2. So that is 2p minus 12, which is the previous term, p minus 3 lots of 2p minus 12. And now I'm going to simplify this. So the first bracket, leave it as it is. Second bracket becomes p minus 6p, which is equal to p minus, let me break it down, p minus 6p plus 36. First bracket stays as it is. Second bracket becomes minus 5p plus 36. If you expand it, you get negative 10p squared. You get 72p plus 60p, which is 132p. And minus 12 times positive 36 is minus 432, which is what we wanted to show anyway. Okay, part B. Given that x3 is equal to negative 288, so x3 is equal to negative 288, that implies find the value of p minus 10p squared plus 132p minus 432 must be equal to negative 288. Okay, if we take everything to the left-hand side, I get minus 10p squared plus 132p minus 432, add 288, gives me minus 144 is equal to 0. We've got even numbers here, so let's divide by 2. So I end up getting minus 5p squared plus 66p minus 72 is equal to 0. I don't like negative p squared, so let's multiply by minus 1. So I end up getting 5p squared minus 66p plus 72 equals 0. If we factorize this, I've got 5p and p minus 6 here plus, well, minus 12 here as well, because I want positive 72. Negative 6 times negative 12 is positive 72. I get minus 6p minus 60p, which is minus 66p. Okay, which implies that p is equal to 6 over 5, or p is equal to 12. P is equal to 12 as we know p is an integer. Okay, part C. Hence find the value of x4. So let's rewrite this. So x to the power x sub n plus 1, it will be equal to x sub n times p, which is 12, minus 3 times x sub n. So if I want to find out x4, it will be x3 times 12 minus 3 times x3. We know x3 is minus 288, so it will be minus 288 times 12 minus 3 times minus 288. Put this into our calculator, you get minus 252,288. Minus 252,288. A sequence A1, A2, A3 is defined by A1 is equal to K. So A1 is equal to K. To find the next term, it's 4 times the previous term plus 5. Find A3 in terms of K. So A2 will be equal to 4 times A1 plus K, which is equal to 4K, plus 5. 4K plus 4 times A1 plus 5, which is equal to 4K plus 5. A3 is equal to 4 times A2 plus 5, which is equal to 4 times 4K plus 5 plus 5, which is equal to 16K plus 20 plus 5, which is equal to 16K plus 25. Part B showed that the sum of R equals 1 to 4 of AR is a multiple of 5. So I've got A1, A2, A3 already worked out. I need to work out A4. A4 will be 4 times A3 plus 5, which is 4 times 16K plus 25 plus 5, which is equal to 64K plus 100 plus 5, which is equal to 64K plus 105. So sum of R equals 1 to 4 of AR is equal to A1 plus A2 plus A3 plus A4, which is equal to K plus 4K plus 5 plus 16K plus 25 plus 64K plus 105. Now if I collect all the K's together, I get K plus 4K plus 16K plus 64K, which is 85K. All the constants give me 5 plus 25, which is equal to 30. 30 plus 105 is 135. Now I know this is 5 times 85 is 5 times 17, so 5 times 17K plus 27. Therefore, because I can express it as 5 times something, sum of R equals 1 to 4 of AR is a multiple of 5. A sequence x1, x2, x3 is defined by x1 is equal to 1. So x1 is equal to 1. To find x sub n plus 1, which is the next term, it's a times the previous term plus 5. A is a constant. Write down expression for x2 in terms of a. So x2 is equal to a times the previous term, which is x1 plus 5, which is a times 1 plus 5, which is equal to a plus 5. B showed that x3 is equal to this, okay? So x3, using the recurrence relation, is equal to a times the previous term, which is x2 plus 5, which is equal to a times a plus 5, which is equal to a squared plus 5a plus 5. C, given that x3 is equal to 41, then that means we have an expression for x3, a squared plus 5a plus 5 is equal to 41. If I take the 41 to the other side, I get a squared plus 5a, 5 take away 41 is minus 36, is equal to 0. I need to factorize this, which is a and a. Negative 4 plus 9 gives me negative 36. And I get minus 4a plus 9a, which is 5a, which means a is equal to 4 or a is equal to minus 9.